1.8 Electron Cloud Atomic Model. Again, sorry for the nasal, cold-sounding voice. I'm working through stuff. This lesson, we will actually go a little deeper than we need to, but I would say practice harder than you play, so we'll learn a little bit more than we actually need to know for the test, which is totally fine. Without any more, we'll go ahead and get started. The fan pictured here is turned off in the photo on the left and running at high speed in the photo on the right. In the right-hand photo, the blades are moving too fast for you to see the individual blades. You can't tell where any given blade is at any given moment. In some ways, rapidly moving fan blades are similar to electrons moving about the nucleus of an atom. Like fan blades, electrons move very quickly, and we can never tell exactly where they are. If that's the case, how can we represent electrons in models of the atom? Up until about 1920, scientists accepted Niels Bohr's model of the atom. In his model, negative electrons circle the positive nucleus at fixed distances from the nucleus called energy levels. You can see the model in the figure below for an atom of the element nitrogen. Bohr's model is useful for understanding properties of elements and their chemical interactions. However, it doesn't explain certain behaviors of electrons, except for those in the simplest atom, the hydrogen atom. So as we see here, we see these energy levels, and this is nitrogen. So we have 1, 2, 3, 4, 5, 6, 7 positives. That's nitrogen. 1, 2, 3, 4, 5, 6, 7 electrons. So in this model, the electrons look like they nicely go around in circles right around the nucleus like planets would. Okay? But in reality, that's not what's actually happening. What are the chances? In the mid-1920s, an Austrian scientist named Erwin Schrödinger thought that the problem with Bohr's model was restricting the electrons to specific orbits. He wondered if electrons might behave like light, which scientists already knew had properties of both particles, like little points, and waves. Schrödinger speculated that electrons might also travel in waves. Question: how do you pin down the location of an electron in a wave? Answer: you can't specify the exact location of an electron. However, Schrödinger showed that you can at least determine where an electron is most likely to be, so kind of like probability. Schrödinger developed an equation that could be used to calculate the chances of an electron being in any given place around the nucleus. Based on his calculations, he identified regions around the nucleus where electrons were most likely to be. He called these regions orbitals. Again, one of these, we will not learn too much about this, just know that this word exists. As you can see in the figure below, orbitals may be shaped like spheres, dumbbells, or rings. In each case, the number of atoms, the nucleus of the atom is at the center of the orbital. Sorry about that. So the nucleus would be right in the center of this blue sphere. The nucleus would be right in the center of this dumbbell. A fuzzy cloud. Schrödinger's work on orbitals is the basis of the modern model of the atom, which scientists call the quantum mechanical model. The modern model is also commonly called the electron cloud model. That's because each orbital around the nucleus of the atom resembles a fuzzy cloud around the nucleus, like the ones shown in the figure below for a helium atom. The densest area of the cloud is where the electrons have the greatest chances of being. As you can see, we have the nucleus, which is represented by 2 protons and 2 neutrons, and this cloud, this hazy cloud that kind of fades out to nothing. Where the cloud is the brightest, the electrons have a greater chance of being there, and where it's less dense, like lighter shaded, electrons are less likely to be there. All right? In the model pictured in the figure above, where are the 2 helium electrons most likely to be? Answer: the 2 electrons are most likely to be inside the sphere closest to the nucleus where the cloud is the darkest. In summary, Bohr's model of the atom, in which electrons circle the nucleus at fixed energy levels, cannot explain all the behaviors of electrons. In the 1920s, Erwin Schrödinger proposed that electrons travel in waves, which means their exact position cannot be determined. We developed an equation to calculate the chances of an electron being in any given place. Using his equation, he identified regions around the nucleus called orbitals, where electrons are most likely to be. Orbitals are the basis of the electron cloud model of the atom. This model is still accepted by scientists today. So in summary, we've learned a little bit more than we need to know. It's not as simple as the electrons orbiting like planets around the sun. It's a little misleading. For our purposes, we will still think of the atom like that with the electrons and individual shells, but in reality, we don't know exactly where any given electron is at any given time. We just know where it's most likely to be. So, thanks for listening.